Hello there, and welcome to the Sleepy Science Channel. Tonight, we're drifting into a world that exists just beneath our conscious awareness, where invisible molecules travel through the air and speak directly to the oldest parts of the human mind. This is the subtle yet fascinating world of essential oils, a world shaped by plants, chemistry, memory, and the very core of our nervous system itself. Long before we analyze or rationalize our experiences, smells reach our brain. They can soften the breath, slow the heart, or gently lift mood, sometimes before we even realize anything has changed. Across cultures and centuries, humans have returned again and again to aromatic plants because of the effects they can have on the body and mind. Modern science is only beginning to understand why these small signals can create meaningful changes. As we explore this topic together, we'll wander through research, real-world observations, and the quiet ways scent interacts with stress, sleep, focus, and emotion. There is wonder here, but also care, nuance, and respect for how delicate these influences can be. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Let your body soften, and allow your eyes to grow heavy. And let your mind unwind as we explore this fascinating world. Let's begin. The smell of lavender can support deeper, slower breathing. In controlled settings, lavender scent is often paired with a measurable shift toward calmer breathing patterns, which matters because breath is one of the fastest ways to signal safety to the body. When the inhale becomes less sharp and the exhale lengthens, the chest and diaphragm begin to move more efficiently, and that can reduce the feeling of internal rush that stress creates. Researchers have explored lavender in environments where people commonly tense up, like waiting rooms and procedure settings, because it is easy to deliver as a gentle inhaled cue. What makes this fascinating is how quickly the change can begin, sometimes within minutes, without any active instruction beyond simply smelling the air. The effect is not a knockout or a trance. It is more like the volume knob on breath turning down, inviting the body into a quieter rhythm. Peppermint scent can measurably increase alertness during mental tasks. Peppermint is famous for feeling wakeful, and research has tried to test that sensation with objective measures like reaction time, sustained attention, and perceived effort. In studies where people perform repetitive tasks, peppermint aroma can be associated with improved vigilance, meaning fewer mental lapses as minutes pass. Part of the intrigue is that the effect can show up even when the scent is subtle, suggesting that the brain treats it as a cue rather than a distraction. Peppermint also tends to feel clean and sharp, and those qualities can change how a task is experienced, making it feel less draining. This is why it appears in experiments involving driving simulators, proofreading, and timed puzzles. It does not magically create intelligence, but it may nudge the mind toward readiness, like opening a window in a sleepy room. For some people, that tiny shift is surprisingly noticeable. Citrus oils may gently elevate mood by stimulating dopamine pathways. Citrus scents often feel bright, and that lift is not only prolific. Compounds common in many citrus oils, including limonene, have been studied for how they interact with stress and reward-related signaling in the brain. Dopamine pathways are involved in motivation and positive anticipation, and researchers have explored whether uplifting aromas can tilt the nervous system away from threat scanning and toward approach behavior. What is especially interesting is how citrus can act like an emotional reset button in everyday spaces. A brief exposure may make a room feel more tolerable, a chore feel less heavy, or a social moment feel easier to enter. Some studies place citrus aroma in stressful environments and measure changes in self-reported tension as well as physiological signs of strain. The results do not mean citrus is a cure for sadness. They suggest scent can provide a small, real nudge toward lighter emotional tone. Rosemary aroma has been linked to improved memory recall in studies. Rosemary is one of the most intriguing oils for cognition because researchers have looked for a bridge between smell and measurable performance. In some experiments, people exposed to rosemary aroma perform better on certain memory tasks, including recalling details and completing working memory challenges. Even more fascinating, a compound associated with rosemary, often discussed in this research, can be detected in the body after inhalation, and levels have been compared with how well participants perform. That creates a rare moment where scent, chemistry, and behavior line up in a way that can be tested. The experience is not always dramatic. It may feel like thoughts come into focus with less fumbling, or names arrive with fewer blank pauses. Rosemary also has a long cultural history as a symbol of remembrance, which makes the modern research feel almost eerie, like folklore meeting lab instruments. It is a reminder that the nose can be an unexpected doorway into mental clarity. Inhaling eucalyptus can make breathing feel clearer without medication. Eucalyptus often creates a sensation of openness, even when airflow has not objectively changed much. That is because certain eucalyptus compounds can stimulate sensory receptors in the nose and upper airways, producing a cooling, clearing impression that the brain interprets as easier breathing. It is a perception shift, but perception matters, especially during congestion, anxiety, or shallow breathing episodes. Researchers have explored eucalyptus inhalation for comfort during colds and for subjective relief in stuffy environments. Another layer of interest is that eucalyptus aroma can encourage people to take deeper breaths, simply because it feels satisfying to inhale, which can change the entire breathing pattern for a few minutes. This does not replace medical care, and it does not cure infection. What it can do is alter the experience of breath in a way that feels immediate and tangible. Few scents create such a strong bodily illusion with such a small dose. Some essential oils demonstrate measurable antibacterial activity in laboratories. When scientists test essential oils against bacteria, they often use simple but revealing methods, like seeing whether growth slows on a culture plate or whether a liquid sample becomes less cloudy over time. Many oils show some level of activity in these controlled environments, sometimes even against strains that are difficult to manage. That sounds dramatic, but the real fascination is in the details. Oils are complex mixtures, and multiple components can contribute, meaning the effect may not come from a single hero molecule. Researchers also test oils in vapor form, because aroma compounds can spread through air and contact microbes on surfaces. At the same time, lab success does not automatically translate to safe or effective medical treatment in humans. Concentration, exposure time, and skin tolerance change everything. The scientific story is not a simple miracle. It is a careful exploration of how plant chemistry can challenge microscopic life under specific conditions, and why those conditions matter. Tea tree oil can disrupt microbial membranes in controlled experiments. Tea tree is often studied because its components can interfere with the protective outer layer that microbes rely on to survive. In controlled experiments, researchers have observed signs of membrane damage, including leakage of cellular contents and changes in how microbes maintain their internal balance. One reason this is so compelling is that membranes are not optional. If that barrier fails, the microbe cannot regulate what enters and exits, and it quickly loses stability. Tea tree oil is a mixture, but a compound commonly linked with its activity is terpenen 4-ol, which has been investigated for how it contributes to these effects. Scientists may use microscopy, dye uptake tests, or measurements of cellular spill to demonstrate disruption. This is not the same as proving a product will heal a person, and safety matters because concentrated oils can irritate human tissue too. Still, the mechanism is striking. It shows plant chemistry can target fundamental structures that microbes depend on. Certain oils reduce perceived pain by influencing sensory nerve signals. Pain is not only a message from injured tissue. It is also a signal shaped by the nervous system, especially by receptors in the skin that detect heat, cold, pressure, and irritation. Some essential oil components can interact with these receptors, subtly changing how strongly a sensation is transmitted. For example, certain compounds can create a cooling or warming impression that competes with discomfort, shifting attention and altering the way the brain interprets incoming information. Researchers studying aroma and topical application often measure perceived pain during stressful moments, like needle procedures or muscle soreness, because perception is the outcome that matters to the person living in the body. The most interesting part is that two people can experience the same stimulus but report different pain levels after scent exposure, suggesting that sensory signaling and emotional appraisal can be modulated together. This is not a claim that oils erase injury. It is an invitation to notice how surprisingly adjustable pain can be when the nervous system receives new, competing sensory input. Smell reaches the brain faster than touch, sound, or sight. Olfaction has a remarkably direct route. Odor molecules bind to receptors high in the nasal cavity, and the signal travels along the first cranial nerve straight into the olfactory bulb, a brain structure designed to process scent quickly. Unlike many senses, smell does not rely on a long chain of relay stations before reaching key processing areas. That architecture makes scent feel immediate, as if it arrives already loaded with meaning. It is why a faint whiff can pull attention in an instant, even when you are focused on something else. This speed is not just a curiosity. It helps explain why scent is often used in calming routines, why it can interrupt a spiraling thought, and why it can shift the atmosphere of a room with almost no effort. When you inhale an essential oil aroma, you are not only smelling a pleasant note. You are triggering one of the brain's quickest pathways for interpreting the world. Essential oils can influence emotion before conscious thought engages. Emotional appraisal often happens faster than language. The brain can tag an experience as safe, pleasant, sharp, or unsettling before you form a clear opinion about it. Aroma is especially good at this because it plugs into networks involved in feeling and motivation. In studies of scent and mood, people sometimes report a shift in calmness or tension, even when they are not trying to relax, and sometimes before they can explain why they feel different. This is part of what makes essential oils so intriguing. They can operate like background music for the nervous system, shaping tone without demanding attention. Researchers explore this with designs that separate expectation from exposure, measuring changes in anxiety scores, facial muscle responses, or stress markers during challenging situations. The outcome is rarely a dramatic transformation. It is more like a subtle tilt in emotional balance, a small easing of threat, or a gentle lift in resilience. In a stressful world, even small shifts can matter. Chamomile aroma has been associated with reduced nervous system arousal. In studies that track the body's on-edge signals, chamomile is often explored for its ability to soften them. Researchers may look at markers like heart rate, skin conductance, or self-reported tension while people face mild stress, and chamomile scent tends to be linked with a gentle downshift. What makes this captivating is how the experience can feel like permission rather than force. The mind does not switch off, it simply stops bracing. Part of chamomile's long story is that it has been used for winding down in many cultures, and modern experiments try to separate tradition from measurable response. Even the smell alone can become a cue that tells the body, you are safe enough to unclench. That cue can be especially useful when stress is not dramatic, just constant and backgrounded, the kind that tightens the jaw without being noticed. Chamomile invites the nervous system to loosen its grip. Bergamot scent has been shown to lower cortisol in relaxed settings. Bergamot has a bright, almost sparkling aroma, yet its most interesting reputation is not about energy. It is about easing strain. In some research settings, bergamot exposure has been associated with reduced cortisol, a hormone often used as a window into stress physiology. The context matters. Studies commonly place people in calm environments, then measure whether bergamot nudges the body even further toward recovery. That is fascinating because it suggests scent can amplify rest, like making a quiet room feel even safer. Bergamot is also unusual among citrus aromas because it can feel both uplifting and soothing at once, a combination that makes it popular in blends designed for anxious minds that still need to function. The real intrigue is not a dramatic drop or a miracle claim. It is the idea that a tiny airborne signal can shift a hormone pattern the body uses to decide whether to conserve energy or stay on guard. Bergamot is a small lever on a big system. Frankincense aroma may support feelings of calm focus and grounding. Frankincense does not smell like a fresh plant. It smells like resin, heat, and time, and that alone changes how people experience it. In modern use, frankincense is often chosen when someone wants calm without sleepiness, the feeling of being steady and present rather than sedated. Researchers exploring aroma and attention look at tasks that require sustained focus under mild pressure, because that is where calm focus becomes visible. The fascinating part is how a scent can shape mental posture. Frankincense can feel like it slows the internal chatter while keeping awareness clear, as if attention becomes less scattered. Historically, frankincense has been burned in rituals for centuries, which means humans have repeatedly reached for it in moments that demand composure. That cultural pattern does not prove biology, but it is a powerful clue about experience. Frankincense seems to pair well with deep breathing and stillness, making it a natural companion for meditation and work that requires patience. Ylang ylang scent can reduce heart rate in controlled environments. Ylang ylang is a vivid floral aroma that can feel almost like a physical presence in the air. In controlled experiments, it has been associated with reductions in heart rate, which is one of the simplest readouts of whether the body is leaning toward alertness or ease. The reason this is so compelling is that heart rate often changes before we consciously notice stress. You might think you are fine, yet your pulse reveals that your system is still scanning for threat. A scent that helps the heart settle suggests a pathway into calm that does not require willpower. Researchers sometimes pair ylang ylang with measures like blood pressure or subjective relaxation, watching whether the body's numbers match the person's feelings. For some, ylang ylang feels like a softening of urgency, as if the day is no longer chasing them. It is not a guarantee, and it is not for everyone, but the possibility is striking. A floral molecule in the air can touch the rhythm of the heart. Lemon oil aroma has been linked to improved task persistence. Lemon scent is often described as clean and energizing, but one of the more intriguing findings is its connection to sticking with a task. Task persistence is not the same as raw ability. It is the willingness to continue when boredom rises or frustration builds. In studies that measure performance over time, lemon aroma has been associated with people staying engaged longer, which hints at a subtle shift in motivation. The beauty of this effect is how practical it is. It is not about becoming a genius. It is about feeling less tempted to quit. Lemon aroma can also change how a space feels, which matters because environment influences behavior. A room that feels fresher can make a tedious project feel more manageable. Researchers exploring this idea look at attention, mood, and perceived effort, because persistence is partly emotional. When effort feels lighter, we keep going. Lemon may act like a gentle psychological tailwind, supporting endurance through small, steady nudges rather than dramatic pushes. Clary sage scent has demonstrated calming effects on brainwave activity. When scientists study relaxation, they sometimes use brainwave patterns as a proxy for mental state. Clary sage has appeared in research exploring whether aroma exposure can shift these patterns toward a calmer profile. What makes this feel almost futuristic is that it takes a private experience, like I feel more relaxed, and pairs it with an instrument reading from the scalp. In some settings, clary sage aroma has been associated with changes consistent with relaxation and reduced tension, without forcing drowsiness. That matters because many people want calm while still staying awake and capable. Clary sage is also often discussed in relation to stress regulation, and researchers sometimes combine brainwave measures with heart rate or self-reports to see whether multiple systems agree. The fascination lies in the idea that smell, a sense we often treat as decoration, can measurably tune the brain's rhythm. It suggests the nervous system treats scent as information, not ornament, and responds with real electrical shifts. Sweet orange aroma may reduce anxiety in waiting room studies. Waiting rooms are a special kind of stress. Nothing is happening, yet everything feels possible. Researchers have used these spaces to test calming interventions because anxiety rises naturally there, and it is easy to measure. Sweet orange aroma has been studied in such contexts, with findings that suggest it can reduce anxiety for some people. The charm of sweet orange is that it is friendly. It rarely feels heavy or intense, which makes it suitable for shared environments. When used gently, it can change how a room feels, making the air seem less clinical and the moment less threatening. In studies, researchers may track self-reported anxiety, heart rate, or other markers while people sit and wait, then compare outcomes between scented and unscented conditions. The idea is not that sweet orange erases fear. It is that it can soften the sharp edges of anticipation. That alone can matter because a calmer body perceives the same situation as more manageable. Inhaled oils can affect brain chemistry without entering the bloodstream. It is tempting to assume that for something to matter biologically, it must circulate through blood. Smell challenges that assumption. When odor molecules bind to receptors in the nose, they trigger electrical signals that travel into brain networks involved in emotion, attention, and memory. That means an aroma can influence brain state through signaling rather than circulation. This is one reason inhalation effects can feel fast. The response begins as a neural message, not as a chemical traveling through the body. Researchers studying this pathway look at mood changes, stress responses, and cognitive performance, because those are direct outcomes of brain state. The fascinating implication is that you can shift how you feel using an input that never becomes a systemic dose. This also helps explain why two people can respond differently. It is not only the oil, it is the brain receiving the signal, shaped by genetics, experience, and expectation. Inhaled aroma is less like swallowing a substance and more like delivering information to the nervous system. Some aromas trigger parasympathetic rest and digest responses. The parasympathetic system is the body's recovery mode. It slows the heart, deepens digestion, and signals that it is safe to repair and replenish. Some aromas appear to encourage that shift, acting as cues that reduce fight or flight intensity. In research, scientists may look at heart rate variability, a measure often used to infer parasympathetic activity. When variability improves, it can indicate a nervous system that flexes smoothly between effort and recovery. Certain calming scents, especially those people find pleasant, have been linked to these changes. What makes this exciting is that it frames scent as a switch for the body's background settings. The body is always choosing between scanning for danger and supporting restoration. Aroma can gently tilt that choice. This is also why calming oils often pair well with breathing practices. The scent provides a sensory signal, and the breath provides a mechanical signal, and together they can reinforce the same direction. It becomes a quiet conversation with the nervous system. Scent memory can shape emotional regulation more powerfully than logic. A smell can unlock a feeling before you know what the smell is. That is because olfaction is deeply entangled with memory and emotion circuits. Unlike a picture that you can analyze from a distance, a scent arrives inside you, and the body answers quickly. This has huge implications for emotional regulation. If a scent is associated with safety, it can reduce tension even when your thoughts are still worried. If it is associated with stress, it can tighten the chest even in a calm room. Researchers explore this by pairing scents with emotional experiences, then testing how those scents influence mood and physiology later. The result can be surprisingly strong. A tiny odor can shift posture, breathing, and facial expression without any deliberate decision. This is also why personal preference matters so much in aromatherapy. The most effective scent is often the one your history has tagged as comforting. In that way, scent is like a shortcut into the emotional brain, sometimes bypassing the rational mind entirely. Certain oils show antifungal activity against common environmental strains. In laboratory environments, researchers sometimes test essential oils against fungi commonly found in damp buildings, soil, and spoiled materials. These organisms are not simple or fragile. Fungi possess thick cell walls and adaptive defenses that allow them to survive drying, temperature shifts, and chemical stress. When exposed to specific plant-derived volatiles, some fungal colonies grow more slowly, produce fewer spores, or lose their ability to spread evenly across test surfaces. Scientists observe these changes through altered growth patterns, reduced biomass, or visible disruption of colony structure. The results depend heavily on oil composition, exposure time, and concentration. What makes this fascinating is evolutionary context. Plants did not develop aromatic chemistry for human use. These compounds evolved as defensive strategies against microbial threats in soil and air. In controlled conditions, modern science occasionally witnesses those ancient defenses still working, quietly interfering with fungal survival strategies that have existed far longer than humans. Thyme oil has demonstrated strong antimicrobial effects in vitro. In vitro research allows scientists to observe how microbes behave when exposed to precisely measured substances. Thyme oil frequently stands out in these experiments because it can interfere with microbial stability at multiple levels. Bacteria rely on tightly controlled internal conditions to survive, reproduce, and repair damage. Certain thyme oil components challenge that balance, making it difficult for cells to maintain energy production and membrane integrity. Researchers test these effects using growth curves, culture plates, and viability measurements that reveal whether populations slow, weaken, or fail to recover. The consistency of thyme's performance across different testing methods is what draws continued interest. However, potency comes with responsibility. Substances that disrupt microbial systems can also irritate human tissue if misused. Thyme oil demonstrates a central theme in essential oil science. Strength does not equal safety. It reveals how concentrated plant chemistry can be both biologically impressive and demanding of careful handling. Oregano oil contains compounds studied for broad-spectrum activity. Oregano oil attracts scientific attention because it often contains carvacrol, a compound examined across many microbial species. Broad-spectrum activity in laboratory terms does not mean universal destruction. It means researchers observe stress responses in diverse organisms, including slowed replication and reduced resilience. What makes oregano especially interesting is chemical complexity. Microbes exposed to oregano oil face a shifting mixture rather than a single isolated molecule. That complexity can make simple adaptation more difficult. Scientists frequently explore oregano in food science, where controlling spoilage organisms matters for safety and shelf life. The deeper fascination lies in evolutionary biology. Oregano developed aromatic defenses to survive insects, fungi, and microbial competition long before human kitchens existed. When modern experiments detect microbial stress responses, they are witnessing ancient plant strategies, interacting with modern organisms under glass and light. This research does not promise cures. It demonstrates that botanical chemistry can still influence biological systems in measurable, repeatable ways. Cinnamon oil can inhibit bacterial growth on surfaces in tests. Surface-based experiments help researchers understand how microbes survive outside living hosts. In controlled studies, scientists apply diluted cinnamon oil preparations to materials, introduce bacteria, and measure survival after timed exposure. Cinnamon oil is often studied because it can contain cinnamaldehyde, a compound shown to interfere with microbial processes essential for growth. Some research explores cinnamon-infused films and coatings, imagining packaging that discourages bacterial buildup on food surfaces. These studies highlight how chemistry interacts with materials, moisture, and time. Results vary depending on surface texture, absorption, and evaporation rate. Cinnamon oil also illustrates an important contrast. Familiar scent does not mean mild chemistry. At higher concentrations, it can irritate skin and mucous membranes. This dual nature makes it scientifically compelling. A substance associated with warmth and comfort can, under controlled conditions, meaningfully influence microbial survival. It reminds us that scent and biological activity are often inseparable aspects of the same molecules. Clove oil shows notable effectiveness against oral bacteria. The human mouth hosts dense microbial communities that organize into protective clusters on teeth and gums. Researchers study clove oil in this context because eugenol, a major component, has demonstrated activity against bacteria involved in plaque formation. In laboratory settings, scientists observe reduced growth rates, altered behavior, or weakened stress tolerance in certain oral microbes. This aligns intriguingly with clove's historical use in dental comfort practices. However, the goal of such research is not eradication. A healthy mouth depends on balanced microbial ecosystems. The focus is whether clove oil influences harmful strains more strongly than neutral ones, and under what concentrations. Clove oil's potency also demands caution. Concentrated exposure can irritate tissue, which limits how it may be used. That balance between effectiveness and restraint is what makes clove oil fascinating. It occupies a space where tradition, chemistry, and microbiology meet, offering insight without exaggeration or simple solutions. Some oils disrupt biofilms that protect stubborn microbes. Biofilms are cooperative microbial structures that cling to surfaces and resist external threats. Instead of living as isolated cells, microbes embed themselves in protective matrices that limit penetration by chemicals and immune defenses. Researchers study essential oils against biofilms because disrupting structure can matter more than killing individual cells. In controlled experiments, certain oils reduce biofilm thickness, weaken cohesion, or interfere with communication signals microbes use to coordinate. Scientists visualize these changes using staining techniques or measure how easily biofilms detach after exposure. Results vary widely depending on oil type and concentration. Many oils show little effect, while others require higher doses than expected. This research does not suggest simple household applications. It reveals strategy. If a biofilm's architecture weakens, other interventions become more effective. The idea is striking. Plant-derived volatiles may not only challenge microbes directly, but also interfere with the communal defenses that make them so difficult to control. Vapor phase oils can reduce airborne microbial counts in chambers. Some studies examine essential oils as airborne agents rather than liquids. In sealed chambers, researchers introduce microbes into the air or onto exposed surfaces, then disperse specific volatile compounds and measure changes over time. The fascination lies in volatility itself. Certain molecules remain suspended long enough to contact microbes, while others dissipate quickly. Scientists compare oils by persistence, distribution, and safety thresholds for human breathing. Variables such as humidity, airflow, and exposure duration strongly influence outcomes. These experiments do not imply that diffusers sterilize real rooms. Real environments are open systems with fabric absorption and constant air exchange. Still, the concept reshapes how scent is understood. Air is not empty. It is a chemical space. Under controlled conditions, plant volatiles can influence microbial survival within that space. This research highlights aroma as an environmental factor, not just a personal sensory experience. Essential oils may work synergistically when blended carefully. Synergy occurs when combined oils produce effects greater than either oil alone. In research settings, scientists test oils individually, then in blends, to see whether microbial inhibition improves at lower concentrations. When synergy appears, it suggests complementary mechanisms at work. One component may weaken microbial defenses, while another interferes with energy processes. Synergy also matters for safety, since lower concentrations can reduce irritation risk. Beyond microbes, blending influences perception. The brain experiences scent as a unified whole, and balanced blends may be tolerated longer and used more consistently. However, synergy is not guaranteed. Mixing oils can also combine allergens or increase sensitivity if done carelessly. This is why formulation matters. The scientific intrigue lies in cooperation. Plant chemistry does not always act alone. Sometimes it behaves like teamwork, where multiple signals interact to create a more effective and refined outcome than any single component could achieve independently. Concentration dramatically alters whether an oil soothes or irritates. Essential oils produce different effects depending on dose. At low exposure, an aroma may feel calming or supportive. As concentration increases, the same molecules can trigger irritation, headache, coughing, or skin redness. This shift occurs because sensory nerves respond to intensity, not intention. Researchers describe this as dose-dependent response, where changing amount changes both strength and direction of effect. This explains why experiences with oils vary so widely. One person uses a small diluted amount and feels relaxed. Another saturates a space and feels overwhelmed. Neither experience is imaginary. The nervous system is responding appropriately to stimulus level. Understanding concentration is central to responsible use. Essential oils are not inherently gentle. They are concentrated chemical signals. More does not mean better. It means louder. And the body may interpret that loudness as stress rather than support, especially with repeated or prolonged exposure. Dilution can transform potent chemistry into gentle support. Dilution spreads essential oil molecules across a larger medium, reducing intensity at the point of contact. When mixed with a carrier oil, concentrated compounds interact with skin more evenly and evaporate more slowly. This lowers irritation risk and improves comfort without eliminating aromatic effect. Dilution also creates consistency. A diluted blend delivers a predictable experience, while neat application can vary wildly depending on drop size and location. Carriers influence absorption and scent release, shaping how long an aroma lingers and how sharp it feels. This matters for both topical and inhalation use. Lower airborne concentrations are easier on sensitive airways while still providing sensory cues. Dilution is not about weakening effectiveness. It is about control. It allows precise adjustment of signal strength so the nervous system can respond without becoming defensive. In practice, dilution is where essential oils shift from raw plant chemistry into something measured, intentional, and usable. Lavender aroma has been studied for sleep quality improvement. Lavender has been examined in sleep laboratories, hospitals, and home environments because it is simple to use and easy to standardize. In several studies, participants exposed to lavender before bedtime report falling asleep more smoothly and experiencing fewer nighttime awakenings. These subjective reports are sometimes supported by movement tracking that shows longer periods of stillness during sleep. What makes lavender interesting is that it does not behave like a sedative. It does not force unconsciousness or suppress brain activity. Instead, it appears to support the transition phase between wakefulness and sleep, when mental scanning and muscle tension gradually ease. Researchers often compare lavender exposure to unscented controls to separate familiarity from physiological response. Another important factor is consistency. When lavender is used as part of a regular bedtime routine, the scent itself can become a learned cue for rest. Over time, that association may make sleep feel more accessible, even during periods of stress. Cedarwood scent may increase melatonin release indirectly. Melatonin release depends on more than darkness alone. Stress, alertness, and environmental stimulation can delay or blunt its evening rise. Cedarwood has been explored in relaxation-focused settings because it may help reduce arousal that interferes with nighttime hormonal rhythms. Rather than acting directly on melatonin production, cedarwood appears to support conditions that allow natural release to proceed. Researchers often frame this as an indirect pathway, where calming the nervous system reduces signals that keep the brain in daytime mode. Cedarwood's warm, steady aroma is also less stimulating than many brighter scents, which makes it suitable for evening use. In practice, it is often paired with dim lighting and reduced activity to reinforce a nighttime atmosphere. The fascination lies in the chain effect. A scent influences nervous system tone. Nervous system tone influences hormonal timing, and hormonal timing influences sleep readiness. Cedarwood does not add sleep hormones. It helps remove obstacles that prevent them from rising naturally. Sandalwood aroma has been linked to slower pulse rates. Pulse rate reflects how urgently the body believes it needs to respond to the environment. In controlled studies, sandalwood aroma has been associated with modest reductions in pulse for some participants, suggesting a shift toward a calmer physiological state. Researchers often measure baseline heart rate, introduce the aroma, and then track changes during rest or mild tasks. What makes this compelling is that heart rhythm responds quickly to perceived safety. When the nervous system senses less need for vigilance, the heart no longer races to prepare for action. Sandalwood's deep, steady scent profile may contribute to that perception of steadiness. Unlike sharper aromas, it tends to linger, creating a continuous sensory signal rather than a brief burst. A slower pulse can support deeper breathing and reduced muscle tension, both of which are helpful for sleep. Sandalwood is not stimulating, and it is not sedating. It appears to support balance, allowing the body to settle into a rhythm that favors rest. Vetiver scent may promote mental stillness during stress. Vetiver is often explored in situations where stress causes the mind to jump rapidly between thoughts. In research and clinical observations, people exposed to vetiver sometimes report a quieter mental state, with less internal chatter during demanding moments. Scientists interested in this effect examined perceived stress levels, task performance, and physiological arousal markers. One hypothesis is that certain aromas reduce the brain's tendency to constantly reorient attention, which is a key feature of stress. Vetiver's scent profile is heavy and grounding, and it is less likely to evoke food, daylight, or social associations that keep the mind active. This makes it useful during focus or relaxation practices. Personal preference matters greatly. If the scent is disliked, the effect disappears. But when experienced as pleasant, vetiver can act as an anchor. It provides a steady sensory reference point that helps the mind stop scanning and start settling, even when external pressure remains present. Roman chamomile aroma can shorten time needed to fall asleep. Falling asleep requires a narrow window where the body releases alertness without becoming restless. Roman chamomile has been studied because many people experience its aroma as soothing rather than stimulating. In sleep research, participants exposed to calming scents before bed sometimes report shorter sleep onset times, supported by diary entries or simple monitoring devices. The interest here lies in sensitivity. Sleep onset responds to small changes in nervous system tone. A slight reduction in tension or worry can be enough to allow the brain to disengage from wakefulness. Roman chamomile is often used consistently as part of bedtime routines, which allows the scent to become a conditioned signal for rest. Over repeated nights, the brain may begin to associate the aroma with safety and sleep readiness. This learned association can reduce effort at bedtime. Roman chamomile does not override wakefulness. It smooths the transition, helping the body recognize when it is safe to let go. Some oils reduce nighttime restlessness without sedation. Nighttime restlessness often comes from a nervous system that remains partially alert rather than from a lack of sleep drive. Researchers studying calming aromas look for changes in movement during sleep, reported awakenings, and overall sleep satisfaction. Some essential oils appear to reduce tossing and turning without causing heavy sedation. This is important because sedation can interfere with natural sleep architecture and lead to grogginess. Instead, calming scents may help the body stop scanning for threat, allowing deeper stillness to emerge naturally. Studies may use movement tracking or partner observations to measure changes. The appeal of this approach is subtlety. The goal is not to force sleep, but to reduce internal friction. When restlessness decreases, sleep can deepen on its own. This can be especially helpful during travel, stress, or unfamiliar environments. By supporting calm rather than suppressing consciousness, certain oils offer a gentler pathway toward restorative rest. Smell-based relaxation does not impair morning alertness. One advantage of scent-based relaxation is that it does not linger in the body the way many sleep aids do. Research and observation suggest that calming aromas can support nighttime relaxation while leaving morning alertness intact. This is because scent effects are primarily about shifting nervous system state, rather than suppressing brain activity for hours. Once the aroma is gone and daylight cues appear, the body naturally transitions into wakefulness. Studies often rely on self-reported morning clarity alongside sleep quality measures. Participants may feel more rested without experiencing heaviness or mental fog. The brain is especially good at context switching with scent. Nighttime aromas fade, and morning sensory input resets the system. This makes smell-based routines attractive for people who need calm at night but full function the next day. Rather than overriding biology, aroma works with timing and context, supporting rest when needed and releasing its influence when conditions change. Aromatic rituals can reinforce circadian wind-down signals. Circadian rhythms respond not only to light, but also to repeated behavioral cues. An evening aroma ritual can become one of those cues, especially when paired with consistent actions like dimming lights and reducing stimulation. Over time, the brain learns to associate the scent with slowing down. Researchers studying sleep routines emphasize predictability because uncertainty keeps the nervous system alert. Aroma adds a low-effort, consistent signal that marks the transition from day to night. The scent itself does not control circadian clocks. It supports them by reinforcing timing. When the same aroma appears each evening, the body begins to anticipate rest, lowering resistance to sleep. This anticipation reduces the effort required to relax. The fascination lies in learning. The nervous system adapts quickly to patterns, and scent is especially memorable. Used thoughtfully, aromatic rituals can help align behavior with biology, guiding the body toward night through repetition rather than force. Repeated scent exposure can train relaxation responses. When a scent consistently appears during calm activities, the nervous system can learn to associate that scent with relaxation. This process is a form of conditioning. Over time, the aroma itself may begin to trigger elements of the relaxed state, such as slower breathing or reduced muscle tension. Researchers studying this effect track changes across repeated sessions, looking for faster onset of calm responses. The appeal is simplicity. No complex techniques are required. Consistency does the work. The scent becomes a signal that tells the body what is expected. This can be especially useful during stressful periods, when relaxation feels difficult to initiate. Pleasantness is critical. If a scent is disliked, conditioning fails. But when the aroma is enjoyable, repetition strengthens the response. The body begins to recognize the cue automatically. This training does not eliminate stressors. It improves resilience by making calm easier to access. In this way, scent becomes a learned shortcut into a steadier physiological state. Oils may support sleep through habit as much as chemistry. It is easy to focus on molecules and receptors, but habit plays a major role in sleep. Consistent routines reduce uncertainty, and reduced uncertainty lowers arousal. When an aroma is used as part of the same bedtime sequence each night, it becomes a structural element of the routine. Researchers studying sleep hygiene emphasize that predictable patterns matter more than single interventions. Aroma contributes by marking the end of stimulation and the beginning of rest. Over time, the scent carries meaning beyond chemistry. It signals that demands are finished and sleep is approaching. This learned meaning can amplify any calming effects the oil already provides. The fascinating implication is that benefit can increase with repetition, even if immediate effects feel mild. Chemistry and habit work together. A small sensory nudge becomes more powerful when reinforced nightly. In that sense, essential oils support sleep not by acting alone, but by integrating into a reliable behavioral pathway the brain trusts. Peppermint aroma can reduce perceived nausea in clinical settings. Peppermint has been studied in hospitals and care environments where nausea is common, such as after surgery or during certain treatments. Researchers often focus on perceived nausea rather than chemical causes, because perception strongly shapes comfort. In these studies, peppermint aroma is introduced through inhalation, and participants are asked to rate nausea intensity over time. Some report noticeable relief, even when no medication is changed. The fascination lies in sensory competition. Peppermint's sharp, cooling profile stimulates nasal receptors that send strong signals to the brain, which may interrupt nausea signaling pathways. This does not remove the underlying cause, but it can reduce how overwhelming the sensation feels. Peppermint is also familiar and easy to tolerate, which matters when someone already feels unwell. Its effects tend to be short-acting, making it useful for brief episodes rather than long-term control. In clinical contexts, this kind of gentle support can meaningfully improve comfort without adding pharmacological burden. Ginger oil scent has shown promise for motion-related discomfort. Motion-related discomfort arises when the brain receives conflicting sensory information about movement. Ginger has a long history of use for this problem, and modern research has explored whether its aroma alone can help. In controlled settings, ginger scent is sometimes tested during simulated motion or travel scenarios, with participants reporting levels of discomfort and queasiness. The appeal of ginger aroma is that it can feel warming and stabilizing rather than sharp. Researchers suspect it may influence how the brain processes visceral sensations linked to movement. Even small improvements matter, because motion discomfort often escalates quickly once it begins. Ginger aroma does not prevent sensory mismatch, but it may reduce the emotional amplification of that mismatch. This can delay or soften symptoms, making experiences like travel more tolerable. As with many aroma effects, personal preference plays a role. When the scent is perceived as pleasant, the nervous system is more likely to interpret it as supportive rather than intrusive. Spearmint aroma may help reduce appetite awareness temporarily. Appetite is influenced by more than hunger signals from the body. Smell plays a role in drawing attention toward food. Spearmint has been studied for its potential to reduce appetite awareness by shifting sensory focus. In experiments, participants exposed to spearmint aroma sometimes report fewer food-related thoughts and reduced desire to snack between meals. The mechanism is not suppression of hunger hormones. It appears more related to attention and cue interference. Spearmint's clean, non-food associated profile may interrupt craving loops that rely on imagined taste and smell. Researchers measure this through self-reports and food choice behaviors over short periods. The effect is typically temporary, lasting while exposure continues. This makes it interesting for mindful eating contexts rather than weight control claims. Spearmint does not erase hunger. It may quiet mental noise around food, allowing physical hunger signals to be interpreted more clearly. That distinction is subtle but important when considering how scent influences eating behavior. Certain oils stimulate digestive reflexes through smell alone. Digestion begins before food enters the mouth. The body prepares itself through reflexes triggered by sight and smell. Researchers studying aroma exposure have found that certain scents can stimulate salivation and other early digestive responses even in the absence of food. This phenomenon highlights how closely the digestive system is linked to sensory anticipation. Essential oil aromas associated with herbs or spices may activate these reflexes by signaling that nourishment is coming. Scientists observe changes in salivary flow or digestive enzyme activity to measure the response. The interest lies in timing. These reflexes help the body prepare efficiently, which can improve comfort once eating begins. This does not mean scent replaces digestion. It means it participates in preparation. For people with low appetite or sluggish digestion linked to stress, anticipatory cues can matter. Smell-based stimulation works quietly, without forcing the system. It nudges the body into readiness rather than demanding action. Bitter aromas can activate salivary and gastric responses. Bitter taste is often associated with the tongue, but bitter aromas can also trigger digestive preparation. In sensory research, bitter-associated scents have been shown to increase salivation and stimulate gastric signaling pathways. This response likely evolved as a protective mechanism, helping the body prepare to process complex plant compounds. Researchers measure these effects through saliva volume and changes in digestive secretions. The fascination is that smell alone can activate pathways usually associated with taste. Bitter aromas may signal the presence of biologically active substances, prompting the stomach to prepare acids and enzymes. This does not mean bitterness is always pleasant, but physiological response does not depend on liking. It depends on recognition. In modern contexts, bitter aromatic cues are sometimes explored to support appetite awareness or digestive readiness. The effect is subtle and context-dependent. It demonstrates that digestion is not a passive system, waiting for food. It is an anticipatory system that responds to sensory information long before eating begins. Scent can influence digestion before food is consumed. The digestive system operates on prediction. Before food arrives, the brain estimates what is coming and prepares accordingly. Scent plays a major role in this prediction. Studies show that smelling food-related aromas can activate digestive processes such as saliva production and gastric secretions. This preparatory phase is sometimes called the cephalic response. Researchers examine how different aromas influence this response by tracking physiological changes during scent exposure alone. The fascinating aspect is efficiency. When the body prepares early, digestion can proceed more smoothly once eating begins. Stress can disrupt this process by keeping the nervous system alert rather than receptive. Pleasant aromas may counteract that effect by signaling safety and familiarity. This does not mean scent determines digestion quality on its own. It contributes a layer of readiness. The digestive system listens to sensory input as much as to nutrients. Smell is one of the first signals it receives, shaping what happens next. Aromas may prepare the gut through anticipatory signaling. Anticipatory signaling refers to the body's habit of preparing systems before an event occurs. The gut is especially sensitive to this process. When certain aromas are detected, neural pathways signal that digestion may soon be required. Researchers studying this phenomenon observe changes in gut motility and enzyme readiness linked to sensory cues. The intrigue lies in timing. These responses occur before food intake, meaning smell alone can shape digestive conditions. This is beneficial because digestion requires coordination across multiple organs. When preparation begins early, that coordination improves. Stress and distraction can block anticipatory signals, leaving the gut underprepared. Gentle, familiar aromas may help restore that signaling. This does not guarantee perfect digestion, but it may reduce discomfort associated with rushed or tense meals. Anticipatory signaling highlights how integrated the body truly is. The gut does not operate in isolation. It listens closely to the environment, and smell is one of its most reliable early messengers. Essential oils interact with the vagus nerve indirectly. The vagus nerve connects the brain to many internal organs, including the heart and digestive tract. It plays a central role in calming and restorative processes. Essential oils do not touch the vagus nerve directly, but they can influence the signals that travel along it. In research, calming aromas are associated with changes in heart rate variability, a marker often linked to vagal activity. This suggests that scent can shift autonomic balance toward rest. The mechanism likely involves sensory input reducing perceived threat, which allows vagal pathways to become more active. This interaction helps explain why certain aromas influence both mood and digestion. The vagus nerve coordinates those systems. When it is supported, the body transitions more easily into repair mode. This is not a switch that scent flips instantly. It is a gentle modulation. Essential oils act as background cues that shape nervous system tone, indirectly influencing one of the body's most important regulatory highways. Relaxation scents can support smoother digestive rhythms. Digestion relies on rhythm. Muscles contract in waves, enzymes are released in sequence, and timing matters. Stress can disrupt these rhythms by shifting the body into alert mode. Relaxation-focused aromas are studied because they may help restore smoother digestive patterns by reducing nervous system tension. Researchers explore this through measures of gut motility and self-reported comfort after meals. When the body perceives safety, digestive processes can proceed without interruption. Calming scents may support that perception. The fascination is that digestion is not only mechanical. It is sensitive to emotional state. A relaxed nervous system allows digestive signals to flow more predictably. This does not mean aroma treats digestive disorders. It means it can influence the conditions under which digestion occurs. By supporting relaxation, scent may indirectly support digestive ease. This connection illustrates how closely emotional regulation and physical processes are linked, especially in systems that rely on timing and coordination. Stress reduction often improves digestion more than stimulation. When digestion struggles, the instinct is often to stimulate with strong flavors or additives. Research suggests that reducing stress may be more effective. Stress diverts blood flow away from the digestive tract and disrupts signaling. Calming approaches, including relaxation-inducing aromas, may support digestion by restoring normal nervous system balance. Studies examining digestive comfort often find that perceived stress levels strongly correlate with symptoms. When stress drops, digestion often improves without direct stimulation. This highlights an important principle. The digestive system works best when it feels safe. Overactivation can worsen discomfort. Aroma-based relaxation does not force digestion. It removes barriers. By quieting the stress response, the body can redirect resources back to digestion naturally. This perspective shifts focus from pushing the system to supporting it. It also explains why gentle, calming scents are often favored around meals in traditional settings. Stress reduction is not passive. It is an active contributor to digestive health. Tea tree oil has been studied for acne-related bacteria. Acne involves more than surface oil. It includes inflammation, clogged pores, and the activity of specific skin-dwelling bacteria. Tea tree oil has been studied in this context because certain components can affect bacteria linked to acne development. In research settings, diluted preparations are compared with placebos or standard treatments, focusing on changes in lesion count, redness, and overall skin appearance. What makes tea tree compelling is that its activity appears more selective than harsh antiseptics, meaning it may reduce problematic bacteria without stripping the skin entirely. Researchers also pay close attention to irritation rates because acne-prone skin is often sensitive. Results suggest that careful dilution is essential for comfort and effectiveness. Tea tree oil does not act overnight, and it does not address every factor involved in acne. Its interest lies in balance. It represents an approach that targets microbial contribution while respecting the skin's need for barrier integrity and gradual healing over time. Lavender oil can support wound comfort in diluted topical use. Lavender oil has been examined in studies focused on minor skin injuries, particularly for comfort rather than rapid closure. Researchers explore whether diluted topical application influences redness, irritation, or perceived discomfort during healing. One reason lavender is studied is its relatively gentle profile compared to more aggressive oils. In controlled use, participants sometimes report reduced stinging or tension around healing skin. This does not mean lavender replaces proper wound care. Cleaning, protection, and medical attention remain primary. The interest lies in sensory experience. Healing skin can feel tight, itchy, or unpleasant, and comfort can influence how people care for wounds over time. Researchers also examine how lavender interacts with skin regeneration processes, noting that inflammation level plays a role in healing quality. Proper dilution is critical because undiluted application can irritate damaged tissue. Lavender's appeal is not speed or power. It is its potential to make the healing process feel calmer and more tolerable. Certain oils influence skin inflammation signaling pathways. Skin inflammation is controlled by signaling molecules that tell cells when to react and when to calm down. Researchers study essential oils to see whether certain components influence these signaling pathways in laboratory models. Instead of focusing only on microbes, these studies examine how skin cells respond to stress or irritation. Some oil constituents appear to reduce signals associated with excessive inflammation, while others may increase them depending on concentration. This is why results vary widely across oils and doses. The fascination lies in nuance. Skin is not passive. It actively communicates through chemical messengers, and small external inputs can influence that conversation. Researchers use cell cultures and biochemical markers to track these effects. This does not mean essential oils treat inflammatory skin conditions. It means they may influence processes involved in redness and irritation under controlled conditions. Understanding this helps explain why some oils feel soothing when diluted correctly, while the same oils can feel aggravating when misused. Frankincense compounds have been studied for skin cell support. Frankincense has drawn research interest because certain compounds appear to influence how skin cells behave during repair and maintenance. In laboratory studies, researchers observe whether these compounds affect cell turnover, stress response, or resilience when exposed to irritation. The emphasis is not cosmetic perfection. It is cellular behavior. Healthy skin depends on balanced renewal rather than rapid change. Frankincense is often studied for its interaction with inflammatory processes that influence how skin ages and recovers. Researchers examine markers related to cell structure and response to oxidative stress. These studies remain controlled and limited, but they help explain why frankincense appears in many traditional skin care practices. Importantly, frankincense oil must be diluted appropriately because concentration changes effects dramatically. Its interest lies in subtle support rather than aggressive action. Frankincense does not force regeneration. It may help create conditions where skin cells function more steadily, which over time can influence texture and comfort. Some oils increase skin permeability, enhancing absorption. The skin barrier protects the body, but it also limits absorption of helpful substances. Researchers study essential oils because some components can temporarily increase skin permeability. This effect allows other substances to pass through the outer layer more easily. Scientists measure this by tracking how quickly compounds penetrate skin models when combined with certain oils. The fascination is that permeability is a double-edged effect. Increased absorption can enhance delivery of beneficial ingredients, but it can also increase irritation risk. This is why formulation matters so much. Oils that alter permeability must be used carefully and intentionally. Researchers often explore this effect in pharmaceutical and cosmetic science, not casual application. Understanding permeability explains why essential oils can feel powerful even in small amounts. They change how the skin behaves as a barrier. This property can be useful in controlled formulations, but it also underscores why undiluted use can overwhelm the skin's defenses and lead to sensitivity. Improper use can damage skin despite natural origins. The idea that natural substances are always gentle is misleading, especially with essential oils. These oils are concentrated chemical extracts, not diluted plant waters. Improper use, such as applying undiluted oils directly to skin or using them repeatedly without breaks, can lead to irritation, burns, or long-term sensitivity. Researchers and clinicians document cases where misuse disrupts the skin barrier, leading to redness, peeling, or allergic reactions. The damage does not come from toxicity alone. It comes from overwhelming the skin's ability to recover. Skin thrives on balance, not constant stimulation. Essential oils can interfere with that balance when applied too frequently or too strongly. This is why education and caution are emphasized in responsible use. The fascination here is not fear. It is respect. The same chemistry that makes essential oils biologically active is what requires careful handling. Natural origin does not reduce potency. It explains it. Patch testing reveals how individual chemistry changes outcomes. People often react differently to the same essential oil, and patch testing helps explain why. In patch testing, a diluted oil is applied to a small area of skin and observed over time. Researchers and practitioners use this method to detect irritation or sensitivity before wider use. Individual skin chemistry varies based on genetics, immune history, and barrier strength. These differences shape how skin responds to external substances. Patch testing reveals that reactions are not random. They reflect personal biology. Some people tolerate oils easily, while others develop redness or itching even at low concentrations. This variability is why generalized advice can fail. What works for one person may not work for another. Patch testing respects that reality. It allows the skin to communicate its limits quietly rather than through widespread reaction. The deeper insight is that essential oil use is not only about the oil. It is about the interaction between the oil and the person using it. Oils behave differently on dry versus oily skin. Skin type strongly influences how essential oils are experienced. Dry skin lacks sufficient surface lipids, which can make it more vulnerable to irritation. Oily skin has more natural oils that can dilute and distribute essential oil components differently. Researchers studying topical application observe variations in absorption rate, evaporation speed, and sensation based on skin type. On dry skin, oils may penetrate more quickly, increasing intensity. On oily skin, they may spread more evenly but linger longer. These differences help explain why the same oil can feel soothing to one person and overwhelming to another. Skin type also affects how carrier oils perform, which influences overall formulation behavior. Understanding this variability helps prevent misuse. Essential oils are not one size fits all. Their interaction with skin depends on moisture level, barrier integrity, and natural oil production. Recognizing these factors turns application from guesswork into informed practice. Skin warmth alters how quickly aromas evaporate. Temperature changes how essential oils behave on skin. Warmer skin increases evaporation speed, releasing aroma molecules more quickly into the air. Researchers studying topical application account for this by controlling temperature, because evaporation influences both scent strength and duration. On warm areas of the body, an oil may smell stronger at first but fade faster. On cooler areas, aroma may develop more slowly and last longer. This affects perception and comfort. Rapid evaporation can create an intense initial burst that feels overwhelming, while slower release feels gentler. Skin warmth also influences absorption rate because heat increases molecular movement. This is why exercise, fever, or ambient temperature can change how an oil feels. The fascination is practical. Application location matters. Understanding evaporation helps explain why oils behave differently throughout the day and across body areas. Scent is not fixed. It is shaped by the living surface it touches. Carrier oils dramatically change essential oil behavior. Carrier oils are not neutral backgrounds. They shape how essential oils spread, absorb, and evaporate. Researchers and formulators study carrier properties such as viscosity, fatty acid profile, and absorption speed. The light carrier may allow faster penetration and quicker scent release, while the heavier carrier slows absorption and softens intensity. This dramatically changes the user experience. The same essential oil can feel sharp in one carrier and gentle in another. Carriers also influence skin barrier support, which affects irritation risk. This is why formulation is as important as oil choice. Carrier oils determine dose distribution and contact time. They transform concentrated chemistry into something controllable. Without carriers, essential oils behave unpredictably. With them, behavior becomes measurable and adjustable. This relationship explains why traditional oil-based preparations persist across cultures. Carrier oils are not dilution by weakness. They are design tools that allow essential oils to interact with skin safely and consistently. Inhaling oils can alter heart rate variability. Heart rate variability reflects how flexibly the nervous system responds to change. Higher variability is generally associated with better stress resilience and recovery. Researchers studying aroma exposure sometimes measure this marker because it provides insight into autonomic balance. In controlled settings, inhalation of calming scents has been associated with shifts in heart rate variability that suggest increased parasympathetic influence. This does not mean the heart slows dramatically. It means the timing between beats becomes more adaptable. That adaptability allows the body to respond to stress without staying stuck in high alert. Scientists often examine these changes during rest or mild stress tasks to see how quickly the body recovers. The fascination lies in subtlety. A simple sensory cue can influence a deeply regulated physiological pattern. Heart rate variability is not consciously controlled, yet it responds to perceived safety. Aroma may help communicate that safety quietly, supporting recovery without requiring effort or deliberate relaxation techniques. Some scents measurably lower blood pressure during stress. Blood pressure rises naturally during stress as the body prepares for action. Researchers interested in non-pharmacological support examine whether calming aromas influence this response. In controlled experiments, participants exposed to certain scents during stressful tasks sometimes show smaller blood pressure increases compared to unscented conditions. Scientists measure this using standard cuffs or continuous monitoring. The important detail is timing. The effect often appears during or immediately after stress, suggesting aroma may support faster physiological settling. This does not replace medical treatment for hypertension. It highlights how sensory context can influence acute stress reactions. The nervous system plays a major role in blood pressure regulation, especially in short-term fluctuations. When perceived threat decreases, vascular tension can ease. Aroma may contribute by reducing vigilance rather than directly acting on blood vessels. The appeal of this research is its gentleness. A non-intrusive sensory cue may soften the body's stress response, making recovery smoother and more efficient. Essential oils can influence autonomic nervous system balance. The autonomic nervous system constantly shifts between activation and recovery. Stress pushes it toward alertness, while rest allows repair. Researchers studying essential oils often frame their effects in terms of this balance. In experiments, exposure to certain aromas is associated with reduced sympathetic activity and increased parasympathetic tone. Scientists infer this through markers like heart rate variability, breathing patterns, and subjective calm. What makes this compelling is that balance matters more than suppression. The goal is not to shut down alertness, but to restore flexibility. Essential oils appear to act as contextual signals rather than direct controllers. They influence how safe or demanding an environment feels. When the nervous system perceives less threat, it naturally shifts toward recovery. This perspective helps explain why the same oil can feel calming in one context and neutral in another. The autonomic system responds to meaning, and aroma contributes to that meaning through memory, preference, and sensory interpretation. Relaxing aromas can shorten recovery after acute stress. After a stressful event, the body does not instantly return to baseline. Heart rate, breathing, and muscle tension can remain elevated. Researchers examine recovery time because prolonged activation contributes to fatigue and burnout. In some studies, exposure to calming aromas after a stressor is associated with faster normalization of physiological markers. Scientists measure how quickly heart rate slows, breathing steadies, or stress hormones decline. The fascination lies in recovery rather than prevention. Stress is unavoidable. Recovery determines long-term impact. Aroma may support recovery by signaling that the challenge has passed. This signal allows the nervous system to disengage from defensive mode sooner. The effect is not dramatic or immediate for everyone. It is subtle and context-dependent. But over repeated exposures, faster recovery can accumulate into meaningful resilience. Supporting recovery is often more practical than trying to avoid stress entirely, and scent offers a low-effort way to assist that process. Stimulating oils can increase perceived energy without caffeine. Perceived energy is not identical to physiological arousal. Researchers distinguish between feeling alert and having elevated heart rate or stimulant load. Some stimulating aromas appear to increase subjective energy without the side effects associated with caffeine. In studies, participants exposed to certain scents report feeling more awake or motivated during tasks, even when objective measures remain stable. This suggests the effect operates through attention and mood rather than chemical stimulation. Aroma can shift how effort feels, making tasks seem more approachable. Scientists examine this by comparing self-reported energy, task engagement, and performance speed. The appeal is flexibility. Aroma-based stimulation fades when exposure ends and does not disrupt sleep later in the day. It can be useful for brief mental demands rather than sustained alertness. This does not replace sleep or nutrition. It highlights how sensory input can shape subjective experience, offering a gentle boost without altering underlying physiology in disruptive ways. Aroma exposure may influence exercise endurance perception. Endurance is partly physical and partly psychological. Researchers studying exercise performance examine not only output but also perceived exertion. Some studies explore whether aroma exposure changes how hard effort feels during activity. Participants exposed to certain scents sometimes report lower perceived exertion at the same workload. Scientists measure this using standardized scales while tracking heart rate and output. The interest lies in interpretation. When effort feels lighter, people may persist longer even without physiological change. Aroma may influence mood, focus, or distraction, all of which affect endurance perception. This does not mean scent increases muscle capacity. It suggests it can influence experience of effort. For activities where motivation matters, such as long or repetitive exercise, perception plays a large role. Aroma exposure is simple and non-invasive, making it appealing for exploratory research. The broader implication is that sensory environment shapes physical experience more than we often realize. Scent can change how hard effort feels subjectively. Subjective effort is a powerful determinant of behavior. Two tasks with identical physical demands can feel completely different depending on mood and context. Researchers investigate scent because it can alter emotional tone quickly. In studies, participants exposed to certain aromas rate tasks as less demanding, even when objective performance is unchanged. Scientists use perceived exertion scales to capture this shift. The fascination is that effort perception influences persistence. When something feels easier, people stay with it longer. Aroma may reduce mental resistance rather than physical strain. This aligns with the idea that fatigue has both central and peripheral components. Scent appears to act on the central component, shaping how the brain interprets signals from the body. This does not trivialize effort. It reframes it. Experience matters. A small sensory shift can meaningfully change willingness to engage. That insight has implications for work, rehabilitation, and daily activities where motivation and endurance intersect. Mental fatigue responds faster to smell than physical fatigue. Mental fatigue often arises from sustained attention rather than muscle use. Researchers studying cognitive performance note that smell can influence alertness more quickly than rest alone. In experiments, aroma exposure sometimes leads to faster improvement in attention and reaction time compared to passive breaks. Scientists distinguish this from physical recovery, which requires time and metabolic repair. Mental fatigue is more sensitive to sensory input. Smell can interrupt monotony, refresh focus, and reduce perceived boredom. The fascination lies in speed. While physical fatigue recovers gradually, mental state can shift within minutes. Aroma does not replace rest, but it can provide a temporary reset that makes continued engagement possible. This is especially relevant in environments requiring sustained concentration. Scent-based cues may help the brain reorient without overstimulation. The effect is not permanent. It fades as exposure ends. But in the right moment, it can make the difference between disengagement and continued function. Oils can shape motivation through emotional pathways. Motivation is closely tied to emotion. When a task feels rewarding or manageable, motivation rises. Researchers explore aroma because it can influence emotional state without requiring conscious effort. In studies, certain scents are associated with improved mood or reduced anxiety, which in turn affects willingness to engage. Scientists measure this through task initiation, persistence, and self-reported motivation. The key is indirect influence. Aroma does not force motivation. It shapes emotional context. When stress decreases or mood improves, motivation often follows naturally. This pathway explains why scent can matter in environments like workplaces or study areas. Emotional tone determines whether effort feels worthwhile. Aroma may contribute by reducing friction rather than adding pressure. The fascination is that motivation is not always about discipline. It is about how the body feels about action. Scent can quietly influence that feeling, nudging behavior through emotional channels rather than conscious decision-making. Performance effects depend heavily on context and expectation. Aroma research consistently shows that context matters. The same scent can produce different effects depending on environment, task, and expectation. Researchers control for this by comparing scented and unscented conditions and measuring belief effects. Expectation can amplify or diminish response. If a scent is associated with calm, it is more likely to support calm. If it is associated with alertness, it may enhance focus. This does not mean effects are imaginary. It means perception and physiology interact. The nervous system responds to meaning. Context shapes meaning. This insight is crucial for understanding why results vary between studies and individuals. Aroma does not act in isolation. It participates in a broader sensory and cognitive landscape. Performance benefits emerge when scent, task, and expectation align. When they do not, effects may disappear. This complexity is not a flaw. It is a reminder that human performance is shaped by interaction between body, brain, and environment. Essential oils can influence immune signaling in lab studies. In laboratory research, scientists sometimes examine how essential oil components interact with immune signaling rather than whole immune responses. Using cell cultures, researchers observe whether certain compounds affect communication molecules that immune cells use to coordinate action. These signals help determine when information should increase and when it should resolve. Some oil constituents appear to modulate these signals under controlled conditions, either amplifying or dampening responses depending on dose. The fascination lies in scale. Immune signaling operates at microscopic levels, yet small chemical inputs can influence those conversations. This does not mean essential oils boost immunity in a simple sense. The immune system requires balance, not constant activation. Lab studies are careful to isolate effects because overstimulation can be harmful. These findings help scientists understand mechanisms, not treatments. They suggest plant-derived molecules can interact with immune communication pathways in measurable ways, offering insight into how environmental chemistry influences immune behavior long before illness ever appears. Some oils reduce inflammatory markers in cellular research. Inflammation is regulated through specific molecular markers that signal when immune activity should rise or fall. In cellular research, scientists test whether essential oil components influence these markers when cells are exposed to stress. Some compounds appear to reduce the expression of markers associated with excessive inflammation under controlled conditions. Researchers measure these changes using biochemical assays rather than subjective reports. The interest here is precision. Cellular models allow scientists to isolate individual pathways without the complexity of a whole organism. This helps clarify how concentration and exposure time change outcomes. Importantly, reduced inflammatory markers in cells do not equal treatment effects in humans. The body integrates many systems at once. Still, these findings help explain why certain oils feel soothing when diluted properly and irritating when overused. Inflammation is not inherently bad. It is necessary for repair. The fascination lies in modulation. Plant compounds may influence how strongly inflammatory signals are expressed, shaping balance rather than shutting processes down. Aroma-induced relaxation supports immune resilience indirectly. Immune resilience depends not only on pathogens, but on the body's internal environment. Chronic stress alters immune signaling and weakens adaptive responses over time. Researchers study aroma-induced relaxation because it may influence immunity indirectly by reducing stress load. In experiments, calming scents are associated with reduced physiological stress markers, which are known to affect immune function. The immune system responds to long-term conditions more than brief moments. When relaxation becomes consistent, immune balance can improve as a downstream effect. This does not mean scent directly activates immune cells. It means it supports the conditions under which immune regulation functions better. Sleep quality, hormone balance, and nervous system tone all influence immune resilience. Aroma-based relaxation may support these factors together. The fascination lies in systems thinking. Immunity is not isolated. It listens to stress, rest, and recovery signals. By influencing relaxation, aroma may contribute quietly to immune stability without acting as a stimulant or suppressant. Stress hormones suppress immunity more than pathogens alone. Research shows that chronic elevation of stress hormones can suppress immune responses more reliably than many everyday pathogen exposures. Hormones like cortisol influence immune cell distribution and signaling, reducing the body's ability to respond effectively over time. Scientists studying immune health emphasize that stress management is a major factor in resilience. This reframes how support is considered. Reducing stress may protect immunity more effectively than adding immune stimulants. Aroma research becomes relevant here because calming scents can influence stress hormone regulation. By supporting relaxation, aroma may help limit prolonged hormone elevation. This does not eliminate pathogens or replace medical care. It addresses vulnerability. The fascination is that immunity is often weakened from within rather than attacked from without. The immune system is sensitive to internal signals about safety and threat. Managing those signals can preserve immune readiness. Stress reduction is not passive. It is an active strategy for protecting immune function in daily life. Calming scents may support immune balance through sleep. Sleep is one of the strongest regulators of immune health. During sleep, immune cells redistribute and signaling pathways recalibrate. Researchers studying aroma effects on sleep examine whether improved sleep quality indirectly supports immune balance. Calming scents associated with better sleep initiation or reduced nighttime disturbance may contribute to this process. The immune system depends on consistent rest, not occasional long nights. Aroma-based sleep support does not act on immune cells directly. It acts on sleep behavior. Improved sleep allows the immune system to perform maintenance tasks that are difficult during wakefulness. This connection explains why poor sleep is linked with increased illness risk. The fascination lies in indirect influence. Supporting sleep through gentle sensory cues may have broader physiological effects than expected. Calming scents are not immune boosters. They may help remove barriers that prevent the immune system from operating at full efficiency. Sleep is the mediator, and aroma can be part of protecting it. Essential oils do not replace immune defenses but can support them. A common misconception is that essential oils can act as standalone immune protectors. Research does not support this idea. Immune defenses rely on complex cellular coordination, memory, and adaptive response. Essential oils cannot replace these processes. However, research suggests they may support immune function indirectly by influencing stress, sleep, and comfort. Scientists emphasize support rather than substitution. When the body is rested and regulated, immune defenses operate more effectively. Essential oils may contribute by shaping internal conditions rather than attacking external threats. This distinction matters. Overstimulation of immunity can be harmful. Balance is key. The fascination lies in restraint. The most effective support is often quiet and indirect. By reducing stress and supporting recovery, essential oils may play a complementary role in immune health. They belong alongside healthy habits, not in place of them. Understanding this prevents exaggerated claims and allows realistic appreciation of where aroma fits within the broader immune picture. Immune effects often come from reduced chronic stress. Chronic stress alters immune signaling over weeks and months, gradually reducing resilience. Researchers studying immune outcomes consistently find stress level to be a major predictor of immune performance. This makes stress reduction a powerful, indirect immune strategy. Aroma-based relaxation becomes relevant because it may help lower baseline stress when used consistently. The immune system responds to long-term conditions rather than isolated moments. Reducing chronic stress allows immune signaling pathways to normalize. This can improve response quality without forcing activation. Scientists measure these effects through hormone levels, inflammatory markers, and illness frequency over time. The fascination is cumulative impact. Small daily reductions in stress can add up to meaningful immune support. Essential oils are not cures. They are tools that may help create calmer internal environments. When stress is managed, immune defenses can allocate resources effectively. This perspective shifts focus from fighting germs to maintaining internal balance that allows immunity to function as designed. Smell-induced comfort can improve recovery environments. Recovery environments influence healing through perception as much as through treatment. Researchers studying hospitals and care settings examine how comfort affects stress and recovery outcomes. Smell plays a role because it shapes how safe and pleasant a space feels. Gentle aromas can reduce anxiety, which influences sleep quality, pain perception, and stress hormone release. These factors all affect recovery speed. Scientists measure outcomes such as patient comfort scores, relaxation markers, and overall satisfaction. The interest lies in environment design. Healing does not occur in isolation from surroundings. Sensory input contributes to how the body interprets its situation. Smell-induced comfort may support recovery by lowering vigilance and allowing rest. This does not replace medical intervention. It complements it. The fascination is subtlety. A non-invasive sensory change can improve how the body experiences recovery. Comfort is not cosmetic. It influences physiology, and smell is one of the fastest ways to shape comfort perception. Placebo-controlled aroma studies still show measurable effects. To separate expectation from effect, researchers designed placebo-controlled aroma studies where participants are unaware of whether a scent is active or inert. In some cases, measurable physiological changes still occur in the aroma group. Scientists track markers such as heart rate variability, stress hormone levels, or task performance. These results suggest that aroma effects are not solely driven by belief. Expectation plays a role, but it does not explain everything. The fascination lies in sensory processing. Smell reaches brain regions involved in emotion and regulation quickly, often before conscious evaluation. This allows aroma to influence state even when expectations are controlled. Placebo-controlled findings help ground aroma research in measurable outcomes. They do not claim dramatic transformation. They demonstrate modest, repeatable effects that persist beyond belief alone. This strengthens scientific confidence that scent can influence physiology directly, even when cognitive bias is carefully managed. Expectation shapes outcomes, but does not create them entirely. Expectation influences how sensory input is interpreted, and aroma research consistently acknowledges this. When people expect a scent to calm them, the effect may be stronger. However, controlled studies show that expectation alone does not account for all observed changes. Physiological responses can occur even when expectations are neutral or masked. This reveals an interaction between perception and biology. The nervous system integrates meaning with sensory data. Expectation adds context, but the signal still matters. Researchers design studies to separate these factors by comparing informed and uninformed participants. The fascination is balance. Neither chemistry nor belief acts alone. Together, they shape outcome. Understanding this prevents dismissal of aroma effects as just placebo while avoiding exaggerated claims. Expectation can amplify or dampen response, but it does not invent it from nothing. Aroma influences the nervous system through both sensory pathways and interpretive layers, creating effects that are real, measurable, and shaped by context. Oils can alter mood within seconds of inhalation. Mood shifts linked to scent often happen faster than people expect. When aroma molecules enter the nose, signals travel quickly to brain regions involved in emotion and motivation. Researchers studying mood changes measure immediate responses such as facial expression, self-reported feeling, or physiological markers like heart rate. In some experiments, participants report emotional changes within moments of exposure, even before consciously identifying the scent. This speed is fascinating because it bypasses deliberate thought. Smell does not need interpretation to have impact. It delivers information directly to emotional processing centers. This helps explain why a space can suddenly feel calmer or brighter after aroma introduction. The change is not dramatic or overwhelming. It is subtle, like a shift in emotional temperature. That subtlety matters. Small mood changes can influence behavior, attention, and stress response. Aroma works quietly, altering internal tone rather than demanding focus. Its power lies in immediacy, combined with gentleness. Emotional shifts often occur before conscious awareness. The brain evaluates emotional significance before thoughts fully form. Smell is especially effective at triggering this process because it connects directly to emotional centers. Researchers studying this phenomenon observe changes in mood indicators even when participants cannot yet describe what they are feeling. This gap between feeling and awareness is revealing. It shows that emotion does not wait for language. Aroma can influence internal state before the mind has time to analyze it. Scientists track this using rapid measures like reaction bias or physiological response. The fascination lies in how much of emotional life happens beneath awareness. A scent can soften tension or increase alertness before a person knows why. This has implications for stress regulation. If emotional shifts begin early, they may prevent escalation before conscious coping is required. Aroma does not argue with the mind. It speaks to systems that act first. That makes it uniquely suited for gentle emotional support in moments when thinking feels slow or overloaded. Aroma preference strongly predicts therapeutic response. Preference plays a critical role in how scent affects the body. Researchers consistently find that aromas perceived as pleasant produce stronger calming or supportive responses than disliked ones. This is not trivial. The nervous system interprets pleasant scents as signals of safety. When a scent is disliked, it can increase vigilance instead. Studies often compare responses to preferred and non-preferred aromas, measuring stress markers or mood changes. The results highlight individuality. There is no universally calming scent. What works depends on personal perception. This explains why standardized recommendations can fail. Aroma is filtered through personal meaning. When preference aligns, effects are amplified. When it does not, effects disappear or reverse. The fascination is personalization. Unlike many interventions, scent demands listening to individual response. Therapeutic potential emerges from alignment rather than force. Preference turns aroma from background input into meaningful signal. It allows the nervous system to relax instead of resist. Cultural scent memory shapes how oils are experienced. Scent memory is strongly influenced by cultural context. Aromas associated with home, tradition, or celebration carry emotional meaning that shapes response. Researchers studying cross-cultural perception find that the same scent can evoke comfort in one group and neutrality in another. This difference arises from learned associations rather than chemistry alone. Cultural experiences teach the brain which smells signal safety, nourishment, or ritual. When an aroma aligns with those learned meanings, emotional response strengthens. Scientists examine this through memory recall, mood reporting, and preference testing across populations. The fascination is that scent carries history. It is not only a chemical signal. It is a memory trigger shaped by environment and upbringing. This has practical implications. Aromatherapy is not culturally neutral. Effectiveness depends on relevance. Understanding cultural scent memory prevents assumptions and improves application. It reminds us that aroma speaks a learned language, and that language differs across communities. One scent can feel calming to one person, activating to another. Individual responses to scent vary widely. Researchers document cases where the same aroma lowers stress for one participant and increases alertness for another. This variability arises from personal history, biology, and learned association. The nervous system interprets scent based on meaning, not just molecular structure. Scientists explore this by comparing physiological responses across individuals exposed to identical aromas. The results show divergence rather than uniformity. This is fascinating because it challenges the idea of universal effects. Aroma does not act like a drug with predictable outcomes. It behaves more like a signal interpreted by context. What feels soothing to one person may feel energizing or distracting to another. This reinforces the importance of personal testing. Effective use depends on response, not reputation. The nervous system responds to what feels safe or useful based on experience. Recognizing this variability shifts aroma from prescription to exploration, where personal feedback guides application. Personal history determines emotional scent associations. Every scent carries personal history. Experience is linked to a smell shape how the nervous system responds later. Researchers studying emotional memory find that scent is especially powerful at retrieving past states. A familiar aroma can evoke calm, sadness, or alertness based on prior associations. These responses occur even when memories are not consciously recalled. Scientists measure this through mood changes and physiological markers during exposure. The fascination lies in durability. Scent associations form early and persist strongly over time. This explains why aroma effects are deeply personal. An oil associated with comfort during childhood may feel instantly calming, while another linked to stress may provoke tension. There is no neutral scent experience. Personal history colors perception automatically. This insight emphasizes respect for individual response. Aroma is not only chemistry acting on receptors. It is memory acting on emotion. Understanding this helps explain why self-selected scents often work better than recommended ones. Familiar smells feel safer to the nervous system. Familiarity signals safety to the brain. When a scent is known, the nervous system requires less vigilance. Researchers studying threat perception observe that unfamiliar stimuli increase alertness, while familiar ones reduce it. This applies strongly to smell. Familiar aromas are processed with less defensive response. Scientists measure this through reduced stress markers and calmer behavior during exposure. The fascination is evolutionary. Familiar smells likely indicated known environments where danger was lower. That pattern persists today. A familiar scent can calm even without conscious recognition. This is why people often prefer consistent aromas for relaxation routines. Novelty can be stimulating, but familiarity supports settling. In therapeutic contexts, familiar scents may be more effective for calming than exotic ones. The nervous system values predictability. Familiar smells provide that predictability quickly and quietly. They help the body decide it is safe to rest. Novel scents can stimulate curiosity and alertness. While familiarity calms, novelty awakens. New scents activate exploratory responses in the brain. Researchers studying attention note that unfamiliar aromas can increase alertness and curiosity. This occurs because the nervous system treats novelty as information worth examining. Scientists measure this through attention shifts, reaction time, and exploratory behavior. The effect is usually brief but noticeable. Novel scents can refresh mental state by breaking monotony. This makes them useful in contexts requiring renewed focus. However, novelty can also increase arousal, which is not ideal for relaxation. The fascination lies in balance. Novelty stimulates, familiarity soothes. Aroma can move the nervous system in either direction, depending on context. Understanding this helps guide use. A new scent in the morning may feel invigorating, while a familiar one at night supports calm. Smell is a directional cue, capable of shifting state based on how new or known it feels. Emotional regulation often improves through ritual repetition. Ritual creates predictability, and predictability supports emotional regulation. Researchers studying habits note that repeated sequences reduce uncertainty and stress. Aroma often becomes part of ritual because it is easy to repeat and consistent. When a scent appears during the same calming activities each time, the nervous system learns what comes next. Scientists examine this through reduced stress responses over repeated sessions. The fascination is learning. The body adapts to patterns quickly. Aroma acts as a marker that says, "This is the regulating part of the day." Over time, the emotional response becomes faster and more automatic. This reduces effort. Emotional regulation no longer requires conscious control. Ritual does the work. Aroma strengthens ritual by adding a sensory anchor that is easy to recognize. This approach does not eliminate emotion. It supports smoother transitions between states. Repetition turns scent into a reliable emotional guide. Scent routines can become anchors during uncertainty. Uncertainty increases stress by forcing constant evaluation. Anchors reduce that load by providing stable reference points. Researchers studying coping strategies note that predictable routines improve emotional stability during uncertain periods. Scent routines are especially effective because smell triggers rapid emotional recognition. A familiar aroma used consistently can create a sense of continuity when other variables change. Scientists observe reduced anxiety and improved mood when stable sensory cues are maintained. The fascination is resilience. Anchors do not remove uncertainty. They help the nervous system tolerate it. Scent routines provide a small island of predictability. This can be powerful during transitions, illness, or life disruption. Aroma does not need to solve problems to help. It offers steadiness. When everything else shifts, a familiar scent can remind the body of safety and continuity. That reminder supports emotional balance when cognitive reassurance feels insufficient. Essential oils have been studied in hospital environments. Hospitals are high-stress environments where anxiety, noise, and unfamiliar routines affect recovery. Researchers study essential oils in these settings to see whether gentle aroma exposure influences patient experience. Studies often place calming scents in waiting areas, recovery rooms, or wards, then measure changes in anxiety, restlessness, or perceived comfort. The interest lies in environment rather than treatment. Hospitals focus on procedures, but emotional state strongly affects how patients cope. Aroma does not interfere with medical care, which makes it appealing as a supportive element. Scientists emphasize safety, low concentration, and patient choice. Results suggest that scent can soften the emotional edge of hospitalization, making spaces feel less intimidating. This does not mean aroma improves clinical outcomes directly. It may improve how patients experience care. That experience matters. Reduced anxiety can influence cooperation, sleep quality, and overall satisfaction. In hospital research, comfort is not a luxury. It is part of holistic care. Aroma exposure can reduce perceived pain during procedures. Pain perception is influenced by emotion, expectation, and attention. Researchers studying aroma exposure during medical procedures examine whether scent changes how pain is experienced. In some studies, patients exposed to calming aromas report lower pain intensity during minor procedures. Scientists measure this using pain scales and physiological stress markers. The mechanism is not numbing. Aroma does not block pain signals. It influences emotional processing and attention. When anxiety decreases, pain often feels less intense. This effect is especially relevant during brief procedures where fear amplifies discomfort. Aroma may provide a competing sensory input that reduces focus on pain. The fascination lies in perception. Pain is not only a physical signal, it is an experience shaped by context. By shaping that context, scent can reduce suffering without altering tissue response. This approach does not replace analgesia. It complements it by addressing emotional components of pain that medication alone may not fully manage. Some oils lower anxiety in dental and surgical settings. Dental and surgical environments commonly trigger anxiety due to anticipation and loss of control. Researchers have studied whether aroma exposure can reduce this anxiety before or during procedures. In controlled settings, calming scents are introduced into treatment rooms or waiting areas, and patient anxiety levels are measured through questionnaires or physiological indicators. Some studies report reduced anxiety scores compared to unscented conditions. The interest lies in accessibility. Aroma is easy to implement and does not interfere with procedures. Reduced anxiety can improve cooperation and overall experience. It may also reduce physiological stress responses that complicate care. Importantly, patient consent and preference are emphasized. Not all scents are welcome in clinical spaces. When chosen carefully, aroma can help create a calmer atmosphere without distraction. This does not change surgical outcomes directly. It changes how patients experience the process. That experience can influence satisfaction, trust, and willingness to return for care, which are meaningful aspects of healthcare delivery. Relaxed patients often require fewer interventions. Stress increases muscle tension, breathing irregularity, and resistance to care. Researchers studying patient outcomes note that relaxed patients often require fewer supportive interventions. When anxiety decreases, patients may tolerate procedures better and require less reassurance or additional medication. Studies examining relaxation strategies, including aroma exposure, observe smoother procedural flow and improved cooperation. The fascination is efficiency. Calm does not just feel better. It changes how care unfolds. Reduced stress can lower blood pressure spikes, stabilize breathing, and improve communication. This can make procedures quicker and less complicated. Aroma contributes indirectly by shaping emotional state. It is not a medical intervention itself. It supports the conditions that allow care to proceed more smoothly. This perspective highlights why comfort measures matter. They are not separate from effectiveness. They influence how resources are used and how patients respond. Relaxation is not passive. It actively shapes the clinical experience and the level of intervention required. Healthcare aromatherapy focuses on comfort, not cure. In medical research, aromatherapy is framed carefully. Its role is comfort support, not disease treatment. Researchers emphasize this distinction to avoid exaggerated claims. Studies focus on anxiety, pain perception, sleep quality, and overall experience rather than clinical cure. This framing is important because it aligns expectations with evidence. Comfort influences recovery indirectly by supporting rest, cooperation, and emotional regulation. Aroma is studied as an adjunct, meaning it works alongside standard care. Scientists design protocols that prioritize safety, patient consent, and low exposure. The fascination lies in humility. Healthcare aromatherapy does not promise dramatic transformation. It offers incremental improvement in how care feels. That improvement can matter greatly to patients. Comfort shapes memory of care, willingness to engage, and trust in providers. By focusing on comfort, healthcare aromatherapy occupies a realistic and valuable role. It respects both science and patient experience without overstating its reach. Gentle scent use can improve patient satisfaction. Patient satisfaction is influenced by emotional experience as much as clinical outcome. Researchers studying healthcare environments examine whether gentle scent use affects satisfaction ratings. In some settings, patients exposed to calming aromas report higher comfort and reduced anxiety, which contributes to positive evaluations of care. Satisfaction is measured through surveys and follow-up assessments. The fascination is perception. Two identical procedures can feel very different depending on environment. Aroma contributes to atmosphere, making spaces feel less sterile or intimidating. This does not compromise professionalism. It humanizes it. Improved satisfaction can influence trust, adherence to recommendations, and willingness to return for care. Researchers emphasize subtlety. Strong scents can be intrusive. Gentle, optional exposure respects individual differences. This research underscores that satisfaction is not superficial. It affects health behavior. Aroma may be a small factor, but small factors accumulate. Improving how patients feel during care supports better engagement and overall healthcare experience. Staff stress levels can shift with environmental aroma. Healthcare staff work under constant pressure, and chronic stress affects performance and well-being. Researchers have explored whether environmental aroma influences staff stress levels in high-demand settings. Studies may measure self-reported stress, mood, or physiological markers before and after scent introduction. Some report modest improvements in perceived stress or fatigue. The interest lies in environment design. Staff are continuously exposed to sensory input, and small changes can accumulate over long shifts. Aroma is non-invasive and does not interrupt workflow. It may contribute to a calmer baseline without requiring breaks or behavioral change. This does not solve systemic issues like workload or staffing. It addresses moment-to-moment experience. Reduced stress can support focus, communication, and emotional resilience. The fascination is shared environment. The same sensory space affects both patients and staff. When designed thoughtfully, environmental aroma may support everyone within it, improving overall atmosphere rather than targeting individuals alone. Calmer environments often improve healing outcomes indirectly. Healing depends on more than medical intervention. Environment influences sleep, stress hormones, and emotional state, all of which affect recovery. Researchers studying healing environments observe that calmer settings are associated with improved rest and reduced stress. Aroma is one element of calm. It contributes to how a space feels. This does not directly heal tissue. It supports conditions that allow healing to proceed efficiently. Reduced stress supports immune function, hormone balance, and restorative sleep. Scientists examine outcomes such as recovery time, sleep quality, and patient comfort. The fascination is indirect influence. Small environmental changes can have system-wide effects over time. Healing is not a single event. It is a process sensitive to context. By shaping context, aroma may support healing indirectly. This perspective values environment as part of care rather than decoration. Calm is not optional. It is a physiological condition that supports recovery across multiple systems. Scent can shape how safe a space feels. Safety perception influences how the nervous system behaves. Researchers studying environmental psychology note that smell strongly contributes to this perception. A space with familiar, gentle aromas often feels more welcoming than one with harsh or unfamiliar odors. This perception influences stress response, posture, and breathing. Scientists measure safety perception through surveys and physiological markers. The fascination is immediacy. Smell communicates safety faster than visual cues. A calming aroma can reduce vigilance almost instantly. This matters in healthcare, workplaces, and homes. Feeling safe allows the nervous system to shift from defense to recovery. This shift affects sleep, digestion, and immune regulation. Scent does not guarantee safety. It influences perception. That perception shapes physiology. Understanding this helps explain why certain environments feel easier to relax in. Aroma becomes part of environmental language, telling the body whether it needs to stay alert or can let down its guard. Environmental comfort supports physiological recovery. Physiological recovery depends on the body's ability to exit stress mode. Environmental comfort plays a major role in that transition. Researchers studying recovery observe that comfortable environments support lower stress hormones, improved sleep, and better autonomic balance. Aroma contributes to comfort by shaping sensory experience. It works alongside lighting, sound, and temperature. The fascination is integration. No single factor controls recovery. Multiple cues combine to signal safety. Aroma is one of the fastest and most direct cues. By improving comfort, it helps the body allocate resources to repair rather than defense. This does not replace medical care or rest. It supports them. Environmental comfort is not indulgence. It is functional. When the body feels supported, recovery processes proceed more efficiently. Scent-based comfort is subtle, but subtle does not mean insignificant. In recovery, small improvements sustained over time can influence outcomes meaningfully. Essential oils can influence behavior through subtle cues. Behavior is often guided by signals we do not consciously notice. Researchers studying environmental psychology observe that scent can shape actions quietly, without instruction or awareness. In experiments, aroma exposure has been linked to changes in patience, cooperation, and task engagement. These effects are not dramatic shifts. They are gentle nudges that influence how situations are interpreted. Smell alters emotional tone, and emotional tone guides behavior. When a space feels calmer or more pleasant, people may move more slowly, speak more softly, or persist longer with tasks. Scientists measure this through observation and behavior tracking rather than self-report alone. The fascination lies in invisibility. People rarely attribute behavioral changes to scent, yet scent participates in shaping response. This makes aroma a powerful background cue. It does not command behavior. It adjusts the environment in which behavior unfolds, allowing different choices to feel easier or more natural without conscious effort. Aroma exposure may affect decision-making under stress. Stress narrows attention and pushes decision-making toward urgency. Researchers examine whether aroma exposure can soften this effect by reducing emotional load. In controlled studies, participants exposed to calming scents during stressful tasks sometimes show less impulsive decision patterns. Scientists track choices, reaction time, and error rates to assess impact. The interest lies in emotional regulation. When stress decreases slightly, cognitive flexibility can improve. Aroma does not provide information or logic. It influences state. That state determines how information is processed. Under calmer conditions, people may consider options more carefully and avoid snap decisions. This does not mean scent makes choices better universally. It shifts conditions under which choices are made. The fascination is indirect influence. Aroma shapes emotional background rather than conscious reasoning. That background matters greatly when pressure is high. By reducing internal urgency, scent may allow decision processes to function with greater balance and clarity. Scents can bias emotional interpretation of experiences. Emotional interpretation shapes how events are remembered and evaluated. Researchers studying scent note that aroma can bias this interpretation by influencing baseline mood. In experiments, participants exposed to pleasant or calming scents may rate neutral experiences more positively than those in unscented environments. Scientists examine this through subjective ratings and recall tests. The fascination is framing. The same event can feel stressful or manageable depending on emotional context. Aroma contributes to that context. It does not change facts. It changes interpretation. This has implications for learning, memory, and social interaction. Experiences paired with positive emotional tone are often remembered more favorably. Scent can quietly influence that tone. This does not imply manipulation. It reflects how perception works. The brain integrates sensory input into meaning. Smell is a powerful contributor to that integration. By shaping emotional backdrop, scent can influence how experiences are felt and later recalled. Smell shapes perception more quietly than sound or sight. Sound and sight demand attention. Smell operates in the background. Researchers note that scent influences perception without requiring focus. This quiet operation makes it especially effective. People may not notice a scent consciously, yet their emotional and physiological state shifts. Scientists study this through changes in mood, stress markers, and behavior without explicit awareness. The fascination is subtlety. Smell does not interrupt thought. It colors it. This allows scent to shape atmosphere rather than compete for attention. In environments designed for calm or focus, this quality is valuable. Loud cues can distract. Quiet cues can guide. Smell reaches brain regions involved in emotion and memory quickly, bypassing deliberate analysis. This allows it to influence perception gently. It does not override senses like sight or sound. It complements them. Smell's quiet presence makes it uniquely suited for shaping how spaces feel and how experiences unfold without conscious distraction. Oils interact with psychology as much as physiology. Essential oils are often discussed in chemical terms, but their effects are equally psychological. Researchers studying aroma recognize that emotional response, memory, and expectation shape outcome alongside molecular interaction. Smell triggers associations stored in memory, which influence mood and behavior. These psychological pathways operate in parallel with physiological responses. Scientists examine both by measuring emotional state and bodily markers. The fascination lies in integration. Psychology and physiology are not separate systems. They interact continuously. Aroma influences both at once. This explains why personal meaning matters so much. The same oil can produce different effects depending on context and history. Understanding this prevents oversimplification. Essential oils do not act like isolated chemicals. They act like signals interpreted by a complex mind-body system. Appreciating this interaction allows more realistic expectations. It highlights why subtle, supportive use often produces better outcomes than forceful application. Gentle effects accumulate with consistency rather than force. Many aroma effects are modest in the moment, but meaningful over time. Researchers studying habit formation note that consistent cues can produce cumulative change. Essential oils often work best when used regularly rather than intensely. A gentle nightly routine may support relaxation more effectively than sporadic strong exposure. Scientists examine this through longitudinal observation rather than single-session results. The fascination lies in patience. The nervous system adapts gradually. Repeated signals shape baseline state. Forceful stimulation can provoke resistance or irritation. Gentle repetition encourages acceptance. This principle aligns with how learning occurs in the body. Small inputs repeated consistently create lasting patterns. Aroma becomes part of that pattern. This does not mean results are guaranteed. It means approach matters. Consistency allows effects to build quietly. Over time, subtle support can become reliable influence. This reframes essential oils as tools for rhythm rather than rescue. Essential oils work best as supportive companions, not fixes. Research consistently shows that essential oils function best alongside healthy habits rather than as standalone solutions. They do not correct complex conditions by themselves. Instead, they support processes already in motion. Scientists emphasize this framing to avoid unrealistic expectations. Aroma may reduce stress, improve comfort, or support sleep routines, but it does not replace medical care or lifestyle change. The fascination is humility. Effective support does not need to dominate. It needs to integrate. Essential oils fit naturally into routines that include rest, movement, and regulation. They enhance experience rather than override biology. This perspective allows appreciation without exaggeration. When used as companions, oils can improve consistency and adherence to healthy behaviors. They make routines more pleasant and easier to maintain. This indirect role may be their greatest strength. Support works when it respects complexity rather than trying to simplify it. Their power lies in small signals repeated over time. Small signals shape large outcomes when repeated. Researchers studying nervous system regulation emphasize that consistent cues recalibrate baseline state. Essential oils deliver small sensory signals that the brain recognizes quickly. Over time, repeated exposure can shape emotional and physiological patterns. Scientists observe this through changes in stress response and habit formation. The fascination is scale. Tiny inputs accumulate into meaningful shifts. Aroma does not shock the system. It teaches it. Repetition allows learning. This learning becomes embodied. The body begins to anticipate certain states when the signal appears. This is how routines become effective. Essential oils fit naturally into this framework because they are easy to repeat and recognize. Their influence grows through familiarity. This explains why dramatic one-time use often disappoints, while gentle regular use builds value. Power does not always come from intensity. Sometimes it comes from quiet persistence. Aroma benefits often emerge through nervous system regulation. Many effects attributed to essential oils can be traced to nervous system regulation. Researchers studying stress, sleep, and mood find that calming aromas influence autonomic balance. This affects heart rate, breathing, and hormone signaling. These changes support broader physiological stability. The fascination lies in central control. The nervous system coordinates multiple body systems. By influencing it, aroma produces widespread effects without targeting each system individually. Scientists examine this through markers like heart rate variability and stress hormone levels. This does not mean aroma acts as medicine. It acts as context. It shapes how the nervous system interprets the environment. When interpretation shifts towards safety, regulation improves. This framework unifies many observations across studies. Sleep improves, digestion settles, and mood stabilizes because the nervous system is less reactive. Aroma becomes a tool for nudging regulation rather than forcing change. Essential oils influence the body by speaking its oldest language. Before language and logic, the body relied on sensory signals to survive. Smell is one of the oldest of these signals. Researchers studying evolution note that scent guided safety, food selection, and social bonding long before conscious reasoning developed. Essential oils tap into this ancient pathway. They communicate directly with systems designed to respond quickly and emotionally. This explains why aroma effects feel instinctive rather than intellectual. The fascination is continuity. Modern humans still carry ancient sensory wiring. Essential oils interact with that wiring by providing familiar types of chemical information. This does not grant mystical power. It grants access. Smell speaks in a language the body understands immediately. By using that language gently, essential oils can influence state without argument or effort. They do not need explanation. They are felt. This is why their effects can feel natural, subtle, and deeply integrated into human experience. As we come to the end of our journey tonight, you may notice how quietly this world has unfolded. We've wandered through the subtle ways essential oils interact with the body, the mind, and the nervous system. Not as loud forces or instant fixes, but as small signals. Signals that travel through the air, touch ancient pathways in the brain, and gently influence how we breathe, rest, focus, and recover. We've seen how scent can soften stress, support sleep, steady emotion, and shape the spaces we move through. How it can affect perception before thought and calm the body without asking for effort. All of it working quietly in the background, like a low tide pulling the day gently away. Nothing rushed, nothing forced, just small influences, repeated, consistent, and kind. Now there's nothing left to learn or hold on to. If your mind feels a little fuller, you can let that fullness drift. If it feels calm, you can allow that calm to deepen. Let your shoulders sink, your jaw soften, and your breathing slow into its own natural rhythm. The day has done enough. Tonight is about rest. If you're still awake and curious, another gentle journey is waiting for you on the screen. And if these quiet explorations bring you comfort, you might consider liking, subscribing, or sharing a thought below. It helps others discover this space too, one calm moment at a time. But for now, allow yourself to let go. Let the room grow still. Let thoughts fade like distant lights. You've arrived exactly where you need to be. Sleep well and good night.